Alright guys, once you have your tin sulfate and copper sulfate solution set up, um, I'll show you how to actually do the electroplating. Now beforehand I took some steel plates and dipped them in that copper sulfate solution, which coated them in copper. So I've got copper coated steel right now that I'm about to tin plate. First I take 2C batteries. Each one is 1.5 volts. Right there I've shown that connecting in a series you get about 3 volts. This would be my voltage source. I found 3 volts is a good voltage for the method of electroplating that I'll be using. Now the way I do this is I just take wire. This was a wire from an old battery charger that had the one end cut off anyway. I'm just taping one electrode to one end of the battery in series setup, and the other end to the other. Now you can use different voltages. You should experiment to see what works best for you. If you're dipping coins, 3 volts is good. I found that a higher voltage leaves a dull gray finish, kind of a powdery surface, and lowering the voltage to 3 volts seems to have improved the process. We've got a voltage tester just to test it again, make sure the connections are good. 3 volts, that'll do. Now I've got my tin electrodes here. I've made sure to connect the one that's going to be, the one in my right hand is going to connect to the steel plates. I made sure that that one was connected to the positive end. You always want the object to be plated to be the anode. It's connected to the positive end of the battery. Now I've taken these copper coated steel plates and used permanent marker. The permanent marker acts as a resist. It resists the electroplating of the tin. Now the way I do this is I've got a voltage between the two electrodes, so the plate's negatively charged, and the wand I've got in my left hand is it's positively charged. And just dipping it in the solution here, you can see that there's a little bit of silver color forming. And I use this wand, being careful not to actually touch the plate and create a short circuit, which will cause burn marks on the plate. And I bring this wand just under the surface, just enough to make contact with the surface, and use it almost as a paintbrush. The tin is being deposited on the copper surface there, wherever I bring that cathode. And I just wave it around until I get a decent tin coating. You can see right here I touched I accidentally touched the plate there, and it caused a little bit of a darkened spot where it cleared a short circuit. Once I'm happy with the result, I'll remove the plate, and now is time to remove the resist. The permanent marker has to come off. Alcohol is great for that. Moving on to the second one. Same setup. Now if I were to do this again, I would make more of the tin to sulfate solution, just because it seemed like the liquid level wasn't very deep, and I had a hard time making sure that the cathode didn't touch the surface of the plate. That really dark spot right there wasn't actually a spot that I touched the plate. That was a chunk of deposited tin that had fallen off the cathode and landed, and due to the positive charge or the negative charge of the plate, it just attracted right away to the surface. Didn't really affect the outcome. I was able to scrub it off, make it uniform. I had to squeeze the battery setup because I think one of the wires was disconnected for just a moment. Once I squeezed it, I noticed bubbles started to come off of that cathode wand I had, so I knew it was working right away. This only takes a few minutes. Total time on this one maybe 2 minutes. Now because I'm plating for artwork, it wasn't real important that I get a really durable electroplate. If I wanted a thicker electroplate, I would use a different setup. This one came out alright. This is nice and clean. I'm happy with the results. What's most important is that the permanent marker came off on this one. Some of the other ones had a little more trouble. So from plain steel to electroplated nameplate.